Good morning. We are looking at arc length and area of a surface of revolution. Hopefully you did your opener and you looked at finding the distance. That's really important for today. We're going to be looking at the length of a curve, which is very important in applications. Thinking of roller coasters or paths, things just aren't in straight lines or straight parabolas. And so when we want the length of that curve, calculus is what comes into place. Now, the whole idea of calculus is taking a complicated problem and breaking it down into pieces. So as we look at this, we're going to use that same idea. Calculus teaches us to break it down into pieces. So if I want to know the length of this curve, right, trying to find the length of that, what I want to do is I want to break down into little pieces and then add up each of those lengths. So if we break it down far enough, then we can use the distance formula, because if we can break it down, then we can consider it little straight lines. So we're going to start with that distance formula that hopefully you reviewed in your opener. And we're going to change it up a little bit. So I'm going to take the x1 minus x2, and I'm going to think of that in terms of delta x. y1 minus y2, I'm going to think of that in terms of delta y. So it's the change in your x, change in y. And hopefully if you remember, this is similar to like Pythagorean's theorem, a squared plus b squared equals c squared. That's where that square root comes from, is to get rid of that squared. Now, what happens next is a little bit of calculus. So as we come down, we're going to divide out the delta x squared. So I'm going to divide everything by delta x squared. So when I do, delta x squared divided by delta x squared is a 1. Delta y squared divided by delta x squared is delta y over delta x squared. And then I'm going to take, as I take that out, I square root the delta x squared. You notice this guy is not in the square root anymore. He's been square rooted of the squaring, and that's where he is. All right, so now this is important because this is the distance of all these little pieces. And so we're going to add them all up. So if you add up a whole bunch of little pieces, that should remind you of summation or integration. So integration is the summation of things. And so we're integrating that whole chunk. And here's that delta x on the end, right? And delta x is often written as a dx. So there's that guy coming out, right? And you're going to summation, so you're going to add up all those little pieces. And in here you've got 1 plus. Now tell me, what is dy over dx? Yeah, dy over dx is your function, is your derivative, right? So that's really your derivative squared. So this gives us this formula for arc length. So take a moment and write that down. It's super important. And if you think about all the pieces, that'll help with your memorization. Why do we have to have the square root? Because it's the hypotenuse, and it's the square root of that. So there's your a squared plus your b squared equals c squared. Now, once you get this set up, the problems really are very straightforward. If I want to find the arc length of this graph, then I'm going to integrate along my interval, so 1/2 to 2. And I'm going to do the square root of 1 plus. Now, notice what I have to do, though. I have to find the derivative. So I've got to find y prime. The derivative of this is going to be 3x squared over 6. Now, this x is in the bottom, so he's kind of like he's x to the negative 1. So it's, plus 1/2, but I'm dividing, so I'm going to, that's why the negative. Negative x to the negative 2. So I'm taking the derivative, he's going down 1. All right, so that's what's going to come in here. But it's going to be squared, so I'm going to reduce this also. So I have x squared over 2 minus 1/2. Let's just keep him separate. Squared dx on the end. These, you definitely want to use your calculator. Just like the previous lessons, your calculator is going to be your friend. Use that FNINT to use that integration and plug that in and get your arc length. Take it your time. If you're having trouble plugging them into the calculator, let me know. Now, surface area, or area of the surface of revolution. So we did arc length. Area of surface of revolution is very similar. So you've got that arc length in here. It's part of the formula right there, arc length, times that radius. This is related to that shell method. So if it's a horizontal axis of revolution, you're going to do 2 pi, the radius times the length of the curve, delta x. Vertical, you're going to do the same thing, but you're going to do it in terms of y. So you've got your dy down here. Again, you've got radius and you've got your arc length. Take a moment, pause the video, get those formulas written down. Very, very important to understand and use. And find the area of surface formed by revolving the graph y f of x equals x squared on the interval 0 to 2 about the y-axis. So if I'm revolving about the y-axis, is that a horizontal or a vertical? Y-axis is vertical. So that means that my integral is going to be in terms of y. So it's very important to notice. Find the area of surface formed by. Okay. So if it's this way, then I've got to solve this. So I've got to go y equals x squared, x equals square root of y. So we're going to have that y in there. Now notice we had a 2 pi, we have our radius, and then we have our square root, don't we? So right here is our radius. Square root is the arc length, so that's going to be the 1 plus your derivative squared. And I'm going to take a moment and find my derivative. So x equals y, I'm going to think of it as y to the 1/2. dx dy would be 1/2 y to the negative 1/2. That's what's going to go in here. All right, let's see. Oh, endpoints. We need endpoints. Because this is dy, we're going to be in terms of y. So we had the 0 to 2, but it needs to be converted. So we've got y equals 0 squared and y equals 2 squared. So y equals 4 and y equals 0. Let's see. And that's your setup. Plug it into your calculator, make the calculator do the hard work, and let that solve. Especially these arc length formulas, you do not want to try to be integrating all this by hand. So use that calculator. If you haven't gotten one that you're using, this is the time to do it. All right, let me know if you have examples on arc length and surface area.